what you can do is you can start with something simpler that doesn't involve necessarily RAWs, and then you just kind of transition into it. Um, and what I have done, sort of, again, I've never really been able to get good results with some of the SLAM and the navigation stack that's part of ROS. Again, there's complexity. There's so many parameters to tweak. It's a big black box. You don't really know how it works. And I tried it. It's kind of sort of working. I just really wasn't happy with it. So again, that's what then led me to try David Anderson's more keep it simple style waypoint navigation. Um, implemented that, but I was still using ROS, but not its navigation stack. I was just using it more for other reasons, just a way of if nothing else, visualize the data, right, and have the different parts of this talk to each other. So it can still be very useful to do certain things, even if you find parts of ROS sort of too overwhelming. And just when I just checked the last time I modified my code base was February last year before work just kind of took over everything, my day job. And so I was just, my next thing on my to-do list that I had just started was actually occupancy grids. But, doing it in a keep it simple style, not leveraging sort of what's built into ROS. I mean, so ROS has a lot of that built in, but again, it gets complicated real quick. But so I just started basically with a sort of basic occupancy grid kind of mappings. Let's just keeping track of occupancy, because I feel once you have that information and you have it in the form of an occupancy grid, you can now make smarter decisions in your navigation, right? Again, you don't have to go all out with some of the fancy algorithms and finding the shortest path, but you can still use the information with simple algorithms, I think, to improve your waypoint navigation, which again a lot of times it very naively will drive towards the target, right? It knows approximately where it's at. It knows the XY of the target. Okay, you drive towards it. Oh, well, something in front of me. Well, so okay, well, let me start to try to avoid that obstacle. But obviously, if you have an occupancy grid, at least a little bit, you'll more quickly know that you're going in circles or you're in a dead end and that sort of thing, right? So again, ROS and the navigation stack, they have all kinds of sophisticated algorithms that are, glued together to, in theory, give you a pretty sophisticated navigation capability. It's just really hard to get
Chris,
to work on your own platform.
I think you've got it. That's the kind of stuff I am looking for. Now, I believe I found Chris Anderson's website. If it's at
David Anderson.
at SMU,
Yeah.
Geology at SMU.
Yes.
Okay.
Yes.
So I'll take a look through that material.
Yeah.
Now, the stuff that you're displaying, is that public or is that your personal note?
Yeah, that's public. I'll put a link to my repository in the chat. I think this slide deck is in there, but yeah, this is just things I put together again last year when I had more time, or earlier last year, in this weekly meeting to talk about what I was doing. But where I left it before I started on occupancy grid stuff is kind of this setup, and again, sounds like something might be interesting to you. It's a combination of ROS and just sort of non-ROS implementations, right? I picked the best of ROS and use it, in a way that makes sense to me, and then, but I don't do everything the ROS way, right? Where I think it's very useful is visualization of the data. Okay, it's just you can't beat some of the built-in tools there for visualizing lighter data. All right, I mean you gotta just see what your robot's seeing, right? It really helps tremendously. And
in a couple of the other groups I belong to, there are a few people with lidars, and they have found they implement ROS for development because they want the imaging, because they learn so much from it. Then they try to use a subset of the logic and implement it on the particular processors they've chosen as onboard equipment.
Mm-hmm.
Yeah, so exactly, the visualization is tremendously helpful, and and again, even if you are developing sort of different parts of the logic, the way that ROS lets you sort of develop different parts of the logic as kind of their own largely self-contained pieces. The concept of, okay, well, I'm a son of something that's publishing certain sensor information. Let's say in the case of my robot, I've got a down-facing line sensor, an array from Pololu, and I got a piece of logic somewhere that's in charge of reading, right, that sensor, and it's just publishing that, making it available, right? So you create that code as its own self-contained module. It's doing just that, and then whoever might be interested in that information, right, just picks it up. So that publish subscribe mechanism, once you get your arms around it, and if you just sort of use the basics of it, it can be pretty useful, right, in development, right? The visualization tool is one subscriber. It picks up whatever you publish, right, and it'll help you visualize it. But other parts of your logic, will also, be designed to sort of pick up certain information, right? So I have, I might have one piece of logic here, some piece of code here running, let's just say a Python script, right, that knows how to interface with a PlayStation 3 Bluetooth controller, right? And it publishes sort of the speed command, right, that I give it, right? But I might have other pieces too that publish speed command, right? If I'm in waypoint navigation mode, in fact, right, that navigation logic is the one that's actually dictating the speed and direction. And so you can put a solution together here from these different pieces in flexible ways, and that isn't really all that overwhelming. It's really when you get into the ROS navigation stack side of things, I find where things get overwhelming, or when you try to do everything the ROS way with all the different kinds of configuration files that they're using in their examples. It just gets out of control pretty quick, but you don't have to do it that way, right? You can keep it simple. You don't have to put every parameter in the configuration file and have layers and layers and layers of include files, if you may, right? And you pretty quickly you just completely lose track of what's going on.
Chris, it sounds like you have not moved on to ROS 2 yet.
No, I haven't moved on to ROS 2. When I was doing this, it just wasn't ready yet.
Yeah, neither is anybody else I know.
Yeah. Now,
Chris, thank you. This is very
Sure.
useful. There's a link to this you mentioned?
I will link to my repo, which I think has this slide in it and other code, but the code won't be of much use without anyone walking you through, but I'll link to it anyway.
Yeah.
What platform do you run this on?
Oh, so I run this on, this is what my setup looks like. So I have a Pi, a Pololu Romy control board that's kind of part of the wheel platform, the chassis I'm using, and that's in charge of a number of things. And then I have another little co-processor here, the Qt Pi, which is in charge of the down-facing line sensor array, and it's in charge of talking to the B&O, IMU.
I see you're using USB to connect the peripheral processors to the Raspberry Pi.
Yep, that was so the same concept there that Pat was talking about. Yep.
And you have an I2C link in there as well.
Yeah, because initially in this direction from left to right, I was just an I2C link and actually in reality, I think that's the only thing I'm using right now. I think because that's what comes with the Pololu support library for their board. They give you code to run on the Pi and on their control board for the two of them to exchange commands, right? So the Pi is the I2C master. You have an API that you call. Okay, you want to know the current value on the two odometry readings, right? boom, you get it back. So they give you code for that, and it's pretty easy to get started with that. I2C can be tricky on the Pi. It can be a little glitchy, and that's why I kind of started doing something just in USB, or really just a serial port in a way, right? A virtual serial port.
I'll be linking two Arduinos to an ESP32 variant, and I plan to use I2C for that. I'm pretty comfortable with it.
Yeah, and on the Pi, again, I've seen occasionally there are glitches. It's not so bad that it can't tolerate it, or usually it knows when the data that it gets back doesn't make sense. Something has happened, so I can usually filter that out. But it can have some challenges.
Chris, I had a question for you.
Yep.
If you're done, Tom?
Yep.
Yes, Pat, thanks.
On your other slide, you showed your motor communicating back. It was the pose and your sensors. So the pose, are you just calculating out a value based on odometry and sending your pose back to the Pi?
So the pose, I am doing odometry, but I'm using the orientation coming from the IMU. I'm not, my theta, right, my angle, my heading. I am not using the heading value that my odometry math is giving me. I am taking in the heading that my IMU is giving me.
Okay, that's what I was wondering, what you're using for pose.
Yeah. But again, X and Y, so I'm using sort of the standard sort of odometry type calculations, which I'm pretty sure, again, on David's website are sort of documented and in lots of places. And yeah, he's also the one who sort of suggested that, I recall, right? He's doing standard odometry, but in some versions of his robots, when he has IMU data, he's just simply pulling in the heading that comes from elsewhere, from another sensor, and he's plugging that into the standard odometry calculations, rather than sort of letting that error accumulate as much as it usually does with pure wheel encoders.
Yeah, okay. And for the IMU, are you reading that just in your loop? So every, 50 milliseconds, 40 milliseconds, whatever? Or are you reading it off of an interrupt?
I am, let me go to that other picture to refresh my memory here. Okay, so yeah, so the IMU, I'm reading that in a small piece of Arduino code here. Was also using Platform IO, and it's just doing it in the loop, I'm pretty sure.
So so you're just reading your X and Y on your accelerometer and.
Yep, again, I don't know, I don't recall if I'm using an Adafruit library or some other library, probably Adafruit for talking to the BNO85, which is an Adafruit board that I have here. And I'm just doing that at a fairly high rate in the loop, I believe, actually, yeah, 100 hertz. I'm reading that at 100 hertz and spitting out the data at 100 hertz.
Okay, so it's a fairly fast update.
Yeah,
Thanks,
I'm
Chris.
spitting out all the data at 100 hertz. That includes, the line sensor array also. I read all of that, and at a fixed rate to spit it out.
So are you doing your programming with your ROS and your programming on the Pi? Are you doing it in C++ or in Python?
So on the Pi, I tend to do Python.
Okay, I'm doing the same thing. It's easy to work in Python. You don't have to compile anything.
Exactly, and the type of Python, and for the most part, I don't think it's slowing things down to a point where it's a concern. But there is obviously some overhead there in Python compared to C++. But I don't think that it's a concern right now, and it's more convenient.
Last question, are you using a launch file from ROS to get everything going?
Yeah, so that's kind of what I meant when I said earlier, look, you don't have to do everything the ROS way, right? Just because they have sophisticated ways to get everything going and to configure things. I just got lost in there, right, with the way they were doing it and some examples. especially in some examples, they tend to be set up in such a way that everything is so flexible and so configurable, but that comes with the cost of just complexity. And so no, I'm actually launching things. I think I literally just have a simple batch file, or meaning a shell script that I use to kick things off, and it's not a lot that I need to kick off. So like I said, there's certain things I just decided it's better to just keep it more simple, even if it means reinventing the wheel a little bit. I don't like to do that, but sometimes if if I end up with a much simpler wheel, then I'm okay with that.
When I did the Foursquare competition remotely here, I was using ROS for the Foursquare on the Wooden Monster robot, and it did quite well. I did, like you, a very hybrid control with ROS and Python, and to launch everything and get it going. I as well found the navigation stack was very overwhelming to try to look at.
Yeah.
And decided I didn't want to get a PhD in ROS, and just I dropped back to Python and working on whatever else I can find.
Yeah. So again, if I ever have time to try to pick this up again, and I just kind of recently started refreshing my memory. Next on my list would be, again, figuring out how to make use of a simple occupancy grid that I started sort of creating code for early last year. Again, keep it simple fashion, and somehow use that to improve the performance of waypoint navigation.
Yeah. I think, Tom, because you haven't probably met David Anderson, one of the things that he would say about all this is you don't need all that crap. He uses this assumption model.
Mm-hmm. Yes.
Okay, and he would say, so in his robots, if you want to go from where you are to where you want to go, it would just go, and then when it sees something in its way, it would just kind of like this assumption model would just kind of like steer it away from it. And when there was nothing in its way, this assumption model would steer it back to it. And that's all you need.
And by the way, that was one of the yellow boxes that I've shown was exactly just that, right? So I think the comment "you don't need all that crap" applies mainly to how it's implemented, right? So the implementation, involving a Pi and 2 other microcontrollers, and here's a Python, or here's ROS in the loop, is a bit heavy and much heavier than necessary to actually have that logic by itself working. I just want to point out, right, in some sense, because I really like that keep it simple approach to getting basic navigation working. I have it almost implemented the way he sort of documents it.
Yeah.
I just implemented it in the framework that I'm using, right? But strictly, if you strip it down to the logic I'm using, it's largely sort of the keep it simple approach.
Yeah.
Just a little bit more stuff flowing around, just because it's happening on top of kind of the ROS data bus. So it's just implemented in a complex fashion.
Chris, I didn't mean to sound like I was saying that.
No, I didn't take it that way. I just wanted to point that out.
I'm just saying, as you know David, so you know exactly what he would say. But that is a model, it's assumption, that if you're looking for simple ways, that you need to, it is very flexible. You ought to go look at some of the things that David has done with his robots. I mean, he's gone around whole big buildings and driven off into the woods and all sorts of stuff successfully using this assumption model. Now, and one of the things that Chris mentioned was how do you keep from ping-ponging? One of the things that I noticed on the way he does things, that at least in some of his cases, how he does it is he picks a direction, left or right. And once he picks that direction, he keeps that direction all the time. So that means if he's going to go around an obstacle, he's always going to go around all the obstacles to the left, or he's going to go to the right. Now I don't know. I think he also has a little more sophisticated stuff, but if you look at it like on short-term problems, like when he went around the big building, that's what he did. He always went around the same direction to keep him from going back and forth over the same piece of ground. So, if you look at that stuff, you learn a lot. Okay.
I certainly intend to go through his website.
Yeah. Because some of it, it's not until you look at the video a few times and you say, well, what's really going on here? But you ought to see. If you go, another place you can go is, I took a challenge to myself. You have to have a reason. Was to go from my kitchen to my hallway, my entry hallway. And there's lots of stuff in the way. So I, did a kind of what do they call it? Dead reckoning approach to it. Okay? And then he did the same thing. He didn't do it in his house. I think he did it in his office. Where he went from where he was into some other place, other room somewhere. And he used his assumption model. And, where mine was real jerky. Boom, boom, boom. His was just so smooth. As it moved. Because he's making, as he approaches a problem, he makes small adjustments to get around it. And when he gets just around it, or just around it plus a little bit, then he just gradually comes back to his original course. It's really nice to watch. But those videos are somewhere in our Robot Builders Night Out virtual videos. And the best way to do it is go to Google and say David Anderson's assumption or something, and it'll show them all up.
I've run into a few other articles on subsumption architecture already.
Yeah.
So I understand from my industrial automation background what they're talking about.
Yeah.
In terms of authors, let me ask you one other question. I've run across a few articles by someone named G.W. Lucas. Does that ring any bells?
Not mine.
This is old. He's done competitive odometry work. Looks like it's well done, but I've only started to read through it.
Yeah. Well, there's a series of lectures on autonomous cars, written by a German professor, and he has like a training class. You can do it. And what he does is he gives you a little assignment. You write a couple of Python scripts, and then you move to the next assignment, and he has like a little model. And he takes you all the way up through Kalman filters and Bayes statistics or methods on how to do it. And it's all in little steps. And it's very useful. I'll try and find his name. If I don't find it tonight, I'll see if I can find it for you to put in the next link. Okay, but that's another series of videos, that I highly recommend. Let me see if I can find his name.
Yeah, without knowing his name, it's hard to tell.
Yeah.
My quick search doesn't help me.
No, I've got to get him. Yes, again, I've mentioned him before. So I mean, if you had a decent search in
DPRG.
Google, you could probably find it. But let's see if I can find his name. Guys, you can talk. You don't have to wait for me. I'm trying to find them find them.
Well, it's that time of the evening when I'm running out of gas anyway.
Yeah. I think it's
Pat, I'll
Klaus.
get back to you tomorrow with a follow-up on your email and some more material. Okay, thanks.
Yeah.
Is that the dude at Tübingen?
It might be. I think his name is Klaus Brimmer. Let's see. Yes, Klaus. I'll see if I can. Okay. I think I've got something I can put on the YouTube here. This guy, I found it very useful. It takes you from a very beginning, assuming you starts with odometry and moves its way up, and you essentially, he has a robot that's in an arena that's navigating around specific obstacles, and he's using the obstacles as to essentially give you coordinates, and so you can measure how the robot path that your robot took against its readings and see how true to what you thought it was going to do that it did. It's very useful set of stuff.
There's a lot of stuff on his channel.
Yeah.
Okay, that's another good reference. Thanks very much.
Okay. Who is this stuff?
So to save the links from the chat, do we just copy and paste like the whole chat, for example? I mean, Google says it doesn't save the chats, right?
Right. You just select it and copy it. It will be. It's always on our website. So that's something you should be able to get it.
Including the chat content?
Yes, all the chat content is it's always on the website. So there's a link to the video. This time there's actually going to be a link to 2 videos because I turned it back on because we were having such a good discussion. And anyway, So anyway, guys, I think it's time we cut it out. It's almost 10. Yeah, it is 10 o'clock.
Excellent stuff. Thanks very much, everybody.
Okay. So go ahead, and I'll see you next week. Hopefully
Bye-bye.
Carl will be back, and we'll have more progress on Robo Columbus or something.
Thanks again, Doug.
Thanks.
Right.
Yeah.